Today we are going to discuss some of the problems on properties of DFT. So first problem, find the circular convolution of the sequences x1 of n is equal to 1, 2, 3, 1, x2 of n is equal to 4, 3, 2, 2. Using time domain approach and verify the result using frequency domain approach. So first we see time domain approach. That means we have to use concentric circle method. We have to find what is the DFT, and frequency domain method means we can use matrix method. Let x3 of n is equal to x1 of n circular convolution of n point with x2 of n. Write the formula. x3 of n is equal to summation m is equal to 0 to 3 x1 of m into x2 of n minus m of 4. Call it as equation number 1, where n varies between 0 to n minus 1, that means 3. First we'll draw x1 of m. x1 of m. This is 0 position, this is first position, second position and third position. So 0 position we have 1, we have to write it in the anti-clockwise direction, 1, 2, 3, 1. Next we have to draw x2 of minus m, or we write x2 of m, x2 of m. x2 of m, once again we have to draw it in the anti-clockwise direction. Value will be 4, 3, 2 and 2. Next we will draw x2 of minus m, that means whatever the things we have drawn in the x2 of m, we have to draw it in the anti-clockwise direction. That means 4, 3, 2 and 2 will come. This is figure number 1, this is figure number 2 and this is figure number 3. Now for reflected signals, plot on the circular scale is clockwise. That means for negative we have to draw it in the clockwise. Now we have to find out x3 of 0, which is equal to summation m is equal to 0 to 3 x1 of m into x2 of minus m of 4. Now we have to multiply the amplitudes of specified points. That means we have to multiply x1 of m with x2 of minus m of 4 points. That means figure number 1 and figure number 3 we have to multiply. So we'll get x3 of 0 is equal to 4 plus 4 plus 6 plus 3, that is 17. Next x3 of 1 is equal to summation m is equal to 0 to 3 x1 of m into x2 of 1 minus m of 4. Now for this we have, for figure number 3, we have to shift the signal in anti-clockwise direction by 1 unit, and we have to multiply same as above. That means x2 of 1 minus m of 4. We have to draw x2 of 1 minus m of 4. That means figure number 3, we have to shift the signal by 1 unit in the anti-clockwise direction. So 4 will go here, 2, 2 and 3. That should be multiplied with x1 of m. That means 1, 2, 3, 1. Then x3 of 1 is equal to 3 plus 8 plus 6 plus 2, which is equal to 19. Similarly, x2 of 2, x3 of 2 is equal to summation m is equal to 0 to 3 x1 of m into x2 of 2 minus m of 4. So we'll write x2 of 2 minus m of 4. That means we have to shift this signal by 1 unit in anti-clockwise direction. So the signal will be 3, 4, 2 and 2, and that should be multiplied with x1 of m. Then x3 of 2 is equal to 2 plus 6 plus 12 plus 2, which is equal to 22. Similarly, last one, x3 of 3 is equal to summation m is equal to 0 to 3 x1 of m into x2 of 3 minus m of 4. So x2 of 3 minus m of 4, signal will be 2, 2, 3, 4. That should be multiplied with x1 of m. We'll get x3 of 3 is equal to 2 plus 4 plus 9 plus 4, which is equal to 19. Then x3 of n is equal to 17, 19, 22 and 19. Call it as equation number 2. Next we go for frequency domain approach. We have to verify the answer by this. We know that if x3 of n is equal to x1 of n convolution with x2 of n in time domain approach, in frequency domain approach, x3 of k is equal to x1 of k into x2 of k, where x1 of k is equal to DFT of x1 of n and x1 of k is equal to summation n is equal to 0 to 3 x1 of n into e power minus j 2 pi nk by n, where k varies between 0 to 3. We can use matrix method to find DFT. We'll get x1 of 0, x1 of 1, x1 of 2 and x1 of 3 is equal to 1 1 1 1 1 1 1 minus j plus j plus j minus j minus 1 minus 1 minus 1 minus 1 1. That should be multiplied by 1 2 3 and 1. So answer will be, first one is algebraic sum It's 7 minus 2 minus j 1, and last one is conjugate of second one, minus 2 plus j. So we can write x1 of k is equal to 7 minus 2 minus j 1 and minus 2 plus j. Next, we have to find out x2 of k, which is equal to DFT of x2 of n. That is, x2 of k is equal to summation n is equal to 0 to n minus 1 x2 of n into e power minus j 2 pi nk by n. Once again, we can use matrix method to find x2 of k, x2 of 2, x2 of 3. Standard coefficient matrix should be multiplied by x of n. 1, 1, 1, 1, 1, 1, 1, minus j plus j minus j, minus 1, minus 1, minus 1, minus 1, into 1. It should be multiplied by 4, 3, 2, and 2. So answer will be 11, 2 minus j, 1 and 2 plus j. Then x2 of k is equal to 11, 2 minus j, 1 and 2 plus j. Now x3 of k is equal to x1 of k into x2 of k. Then x3 of 0 is equal to x1 of 0 into x2 of 0, which is equal to 7 into 11, which is equal to 77. x3 of 1 is equal to x1 of 1 into x2 of 1, which is equal to minus 2 minus j into 2 minus j. Answer will be minus 5. x3 of 2 is equal to x1 of 2 into x2 of 2, which is equal to 1 into 1, that means 1. x3 of 4 is equal to x3 of 3 is equal to x1 of 3 into x2 of 3, which is equal to minus 5. So we can write x3 of k is equal to 77 minus 5, 1 and minus 5. This is x3 of k. We know that x3 of n is equal to IDFT of x3 of k, which is equal to 1 by n summation k is equal to 0 to n minus 1 x3 of k into e power j 2 pi nk by n, which is equal to x3 of n is equal to 1 by 4 summation k is equal to 0 to 3 x3 of k into e power j 2 pi nk by 4. For this also we can use matrix method. Using matrix method, that means x3 of 0, x3 of 1, x3 of 2, x3 of 3 is equal to 1 1 1 1 1 1 1 j minus j and j. Here it is minus 1 minus 1 minus 1 minus 1, and this is 1. That should be multiplied by 77 minus 5, 1 and minus 5, and here we have 1 by n, that means 1 by 4. Then answer will be 17, 19, 22 and 19. Therefore, x3 of n is equal to 17, 19, 22 and 19. Call it as equation number 3. So comparing Equation number 3 and 2, we find that time domain approach is equal to frequency domain approach. Next problem, find the 4-point circular convolution of x of n is equal to u of n minus u of n minus 4, h of n is equal to 2 into u of n minus u of n minus 3. So we can write x of n and h of n. X of n will be 1 1 1 1, 0 position, n is equal to 4, and h of n is equal to u of n minus 3 means it is 0 1 2, the signal will be 1, and that 3 it is 0, and we have to multiply it by 2, so it is 2 2 2 and 0. Let formula y of n is equal to x of n circular convolution with h of n. Y of n is equal to summation m is equal to 0 to 3 x of m into h of n minus m of 4. First draw x of m, x of m. So already we know that this is 0 position and we have to draw it in the anti-clockwise direction. Then we have to draw h of m, once again 0 position, and we have to draw it in the anti-clockwise direction. Then we have to write h of minus m of 4. That means same signal we have to write it in the clockwise direction. Then it is 2, 2, 2 and 0. So let us find y of 0. Y of 0 is equal to summation m is equal to 0 to 3 x of m into h of minus m of 4. So we have to multiply x of m with h of minus m of 4. That means we get 2 into 1, 0 into 1, 2 into 1 plus 2 into 1. That means 2 plus 0 plus 2 plus 2, which is equal to 6. Similarly, y of 1 is equal to, we have to shift the signal by 1 unit in the anti-clockwise direction. So 2 will come here, 0 will come here, remaining values are 2. That means y of 1 is equal to 2 plus 0 plus 6, 2, which is equal to 6. Similarly, y of 2 is equal to 2 plus 2 plus 2 plus 0, which is equal to 6. Y of 3 is also 0 plus 2 plus 2 plus 2, which is equal to 6. Hence, y of n is equal to 6, 6, 6, 6. For each convolution, we have to draw the circle and we have to multiply the signal. Next, we are going to discuss about matrix method of computing circular convolution. The circular convolution of two sequences x1 of n and x2 of n, each of length capital N, is given by x3 of n is equal to x1 of n with n-point circular convolution of x2 of n. Then x3 of n is equal to summation m is equal to 0 to n minus 1 x1 of m into x2 of n minus m of n point. Call it as equation number 1, where n varies between 0 to n minus 1. So from above equation, or from equation number 1, we can write capital N number of equations, each having n number of terms. These n equations can be represented by matrix forms as shown below. That means x3 of n cross 1 order, x2 of n minus m of n cross n into x1 of n of order n cross 1. So we can write like this: x3 of 0, x3 of 1, x3 of 2, x3 of 3. This is left hand side. That means throughout this row n is equal to 0, throughout this row n is equal to 1, throughout this row n is equal to 2, and throughout this row n is equal to 3. Is equal to, according to this equation we have to write, throughout this column m is equal to 0, throughout second column m is equal to 1, throughout the third column m is equal to 2, and throughout next column m is equal to 3. So here throughout this row, that means according to this also it will come into that means throughout this row n is equal to 0 and m is equal to 0 throughout this column. So n is equal to 0, m is equal to 0. That means we get x2 of 0. And throughout this column m is equal to 0. So this term becomes 0. Throughout this row n is equal to 1. So it is x2 of 1. Next, throughout this row m is equal to 2, m is equal to 0, x2 of 2. Next, m is equal to 0, n is equal to 3, x2 of 3. Next column, m is equal to 1, but n is equal to 0 throughout this row. That means x2 of 0 minus 1 of 4, that means 4 minus 1, x2 of 3. So through this 1 and 1, it is x2 of 1. x2 of 0, 1 minus 1 is 0. Next we have x2 of 2 minus 1, x2 of 1. Next we have 3 minus 1, x2 of 2. Here we have m is equal to 2 throughout this column. Here we have 0. 0 minus 2 means it is minus 2. 4 minus 2 means it is 2. x2 of 2, m is equal to 2, n is equal to 1. That means minus 1 will get 4 minus 1 is 3. x2 of 3, x2 of 0, x2 of 1. So throughout this, m is equal to 3, n is equal to 0. 0 minus 3 means it is minus 3. So 4 minus 3 means 1. x2 of 1, x2 of 2, x2 of 3, and x2 of 0. And here it is x1 of 0 throughout this row, x1 of 1, x1 of 2, x1 of 3. So to remember this, we have one idea. We can write like this. So first we have to write x2 of 0, x2 of 1, x2 of 2 and x2 of 3. Then shift this like this, shift this like this, shift this like this, and this will go upwards. Once again, shift this, shift like this, shift like this. This will go to the first row. Once again, shift this, shift it here, shift it here. This will go to this point. So that once you write the given values, directly you can write the remaining values. So we start solving problems. First one, find the circular convolution of the following using matrix method. First one, x1 of n is equal to 2, 1, 1, 1, 2, 1, 2, 1, and x2 of n is equal to 1, 2, 3, 4. Write the formula. Let x3 of n is equal to x1 of n in point circular convolution with x2 of n, which is equal to summation m is equal to 0 to n minus 1 x1 of m into x2 of n minus m of 4, where n varies between 0 to 3. So using matrix method, already we have discussed, we can write the matrix. It is x3 of 0, we have to find out x3 of 1, x3 of 2 and x3 of 3 is equal to the given sequence. First we have to write column wise. x2 of n, it is 1, 2, 3, 4. So next what we have discussed just now is we have to shift the signal to the second point. Like this we have to write, this will go to this position. That means 4 will come here, 1, 2, 3. So once again we have to shift the signal. This will go to next value. That means 3, 4, 1, 2. This will go to next value. We have to shift the signal. 2, 3, 4, 1. That should be multiplied with 2, 1, 2, 1. Now we have to do the matrix multiplication. We will get the answer as 14, 16, 14, 16. Then we can write x3 of n is equal to 14, 16, 14, 16. This is the required answer. Next problem. Find the circular convolution of the sequence x1 of n is equal to 1, 2, 3, 1 and x2 of n is equal to 4, 3, 2, 2 using matrix method. Let y of n is equal to summation m is equal to 0 to 3 x1 of m into x2 of n minus m of 4, where n varies between 0 to 3. Now using matrix method, we can write y of 0, y of 1, y of 2, y of 3 is equal to 1, 2, 3, 1, 1, 1, 2, 3, 3, 1, 1, 2, 2, 3, 1, 1. That is multiplied with 4, 3, 2 and 2. So we get the answer as 17, 19, 22 and 19. That is y of n is equal to 17, 19, 22 and 19.